Trigonometry, simple three-dimensional problems. You will find this on page 457 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. Simple three-dimensional problems. Any object in the real world has three dimensions, such as height, width, and length. Trigonometry can be used to solve three-dimensional problems, and it has a wide application in construction, engineering, and architecture. In the examples, always identify a plane with a 90-degree angle and redraw the plane so that you can see the 90-degree angle and follow the rules of 90-degree triangles. Work with one plane at a time, very important. Let's look at an example. A vertical pole BP stands at one corner of a rectangular field as shown. DC is 10 meters, AD is 5 meters, and the angle of elevation of P from A is 22 degrees. There. Calculate the height of the pole. So it's like we will take this plane. Do you see that one at the back? Take it out. There's the 90 degree and draw it that you can see the 90 degree. Now do exactly the same. You are standing there. Let's get another color. So if I calculate the height of the pole, so that will be PB, that's the one you were looking for. So this will be your opposite, this will be your adjacent, and this will be hypotenuse. So I'm looking for opposite, I have adjacent, and that one is out. So opposite over adjacent, the unknown is on top, so it's a multiplication sum, and I get the height of the pole. The angle of elevation of P from C, it's that angle. So take out that plane again. Okay, now you have the height of the pole. Now, because you approximate, it's going to question B, you can use the answer that is having three significant figures. Okay, so it's not necessary to work with four significant figures. So we can actually scratch that 0. Now, I'm just going to say, okay, I'm looking, so let's just mark. I'm standing here, that's the angle I want. That's the opposite. That's the adjacent. Okay, so opposite over adjacent, and then what will that be? Tan. And then don't forget, you must tell your calculator to go to angles. So press Shift tan bracket 4,04 divide 5, close the bracket equals, and you will get 38.9 degrees. Now, the length of the diagonal of the rectangle ABCD. So let's just move it up. So using Pythagoras, so it's actually, I didn't show you there, but don't forget that that is just a rectangle. Okay, let's just. So in this case, that will be 10, and that one there, let's just see, will be 5, and I'm finding that one. So I'm just using Pythagoras theorem. I'm looking for the long one, so it will be 10 squared plus 5 squared, and I take the square root, and I get the answer. And then the final, the angle of elevation of P from D, it's that angle there. So again, there's the 90. So I have the one of the pole, that was 4.04. I can work with the three significant figures because it was the ending of a question and I went on to B. It's not part of A anymore. If it was just one question, I must use the unapproximated answer. Okay, and then that is, and I have this one, that's the 11.2, don't forget. And then it's again opposite over adjacent, so it's again tan. I must tell my calculator again to go to angles, so I press Shift tan bracket 4.04 divide 11.2, close the bracket equals. So the angle of elevation will be 19.8, and that's how you do it. So always remember what I told you here. Can I show you? Identify a plane with a 90-degree angle and redraw the plane so that you can see the 90 and follow the rules of 90-degree triangles. Let's move on. I want you to stop the video and I want you to do number 1. You can continue the video as soon as you are finished. Okay, let's start. A figure shows a pyramid with a rectangular base ABCD, and a vertex V, okay, vertex V, vertical above B, that's very important, okay. Given that DC is 12 meters, okay, so that's 12, AD is 5, and this one is VB, where is VB? Oh, let's just write it in. Let's just get the color. That is going to be 3 meters. Okay. Calculate angle VCB. VCB. Now again, take out your triangle. Oh, let's just get my... I think that's a good sketch. So that one was 3. Let's just get the pen correct. BC, okay, don't forget, that's B, that's V, and that's going to be C. So BC is going to be 5. And I'm going to say angle VCB, VCB, that angle. So if I'm looking for an angle, I'm standing here. So this is going to be my opposite. The one over the 90 is my hypotenuse, and this will be my adjacent. So it's opposite, adjacent. So what will the function be? I can write it again for you. So, K, to R. Can you see? It's OR. So it's going to be tan of angle VCB, and that is going to be opposite over adjacent. So now don't forget to press on your calculator, shift. You must tell your calculator to go to angles by pressing shift or second function. So shift tan, bracket 3 divide 5, close the bracket. So angle, and don't forget to not just write equal, say angle VCB, and it's 1 decimal place. That will be the angle. And then the last one, so this was A, and the last one, number B, angle VDB, VDB. Now, I just want to show you first in this sketch. So if I'm taking out, so there is the 90. So I'm going to take out the sketch again. That you see, it's always good if you take it out so that you can see the 90 clearly. So this will be D. Okay, this is B. Now let's just get the pen correct. This is D, this is B, and this is V. And then I'm looking for angle VDB. I'm looking for this angle. And now I'm just going to say, what do I have? The problem is, okay, this one is a bit a longer one, because I must first with Pythagoras, and I'm going to just also draw you this. Okay, so can I just show you again? This is D, this is C, this is B, this is A. Okay, so now the first thing, if I know that this was 12, the pen again, Okay. This was 12. This is 5. So I must first find dB. So I can just do it with Pythagoras by saying d, no, I'm saying b, dB squared is going to be 12 squared plus 5 squared, which is going to give me the square root of 169, and that's going to be 13. So that's 13. That's dB. dB. So it means that that is 13. That 13 is that 13. Okay. I have VB. What was VB? That was free. So again, I'm standing here. I want this angle. So this was opposite and this was adjacent. So then I will find opposite over adjacent. So what is it going to be? Tan of angle VDB. And don't forget, it's opposite over adjacent. The opposite is free and the adjacent is 13. So I press shift tan bracket, free divide 13, close the bracket. So don't forget to go to shift, and angle VDB will give you 13, no, that is not nice writing, 13.0 degrees. Okay, and that's my final answer. Let's look at the last example. Okay, now this is a pyramid. So given the pyramid, calculate the length of AC. Now let's just see AC. Now again, this was a square. So it's almost, and I just want to show you here again. It's that square. Just draw it like it looks like a square at least. So that's, oh, my pen again. That's free, that's free. So in this case, okay, that's A, that's B, that's C, and that's D. So if in this case I'm going to say AC, so I'm going to find AC by saying 3 squared plus 3 squared, and I take the square root and I get the answer. Okay. Now, the AC, so the vertical height OH. So if I now have, and I divide it by 2 because it's cutting it in the half, I'm getting that, that's now 2. 2.12. Okay, let's just again. It's 2.12, and now I'm going to see what do I still have. So I'm still going to use Pythagoras because there is my 90 now. So it's the long one squared, I'm looking for a short one, minus this one squared, and I get also 2.12. It's that one, 2.12. Okay. And now I'm asking you the angle OA and the base OA, and the base ABC. So it's that angle. So I have, that is actually exactly the same, so 2.122. So it's opposite over adjacent, so if I say tan, it's exactly 45, and there I showed you in the sketch. Okay, it's just a bit confusing with that being the same, but that was just also coming to the square and the height being at a certain height. Okay. Let's look. I'm going to give you number 2, just to get away a little bit from that, and just to give you a little bit a different one. So stop the video and do number 2. You can continue the video as soon as you are finished. Okay. The diagram shows a cube of length 10 centimeters, everything 10. M is the midpoint of BF. And N is the midpoint of AE. Find angle MEN. Okay, where is it now? let's just find it, M, E, N, or N, E, M. I just want to draw an extra line in here. Okay, so it's M-E-N. Now, if it's exactly in the middle, that is going to be, if this is 10, 10, 10, all 10, so this is going to be, let me just get my pen correct. This is going to be 5. Okay, let's continue. This is going to be 5, and this is going to be 10. So if I must find that angle, M-E-N. So don't forget, this is going to be my opposite. I'm standing there. This is my opposite, and this is my adjacent, and that is my hypotenuse. So opposite over adjacent. So what am I going to write? I'm going to say tan. That's question 2a. Tan of angle NEM equals, and that's opposite over adjacent. So the opposite is going to be 5, and the adjacent is going to be, let's just see, what angle? MEN. MEN. Oh, I see what's the problem. Can I just correct this? The problem is I'm not standing there because it's MEN. So I'm going to show you. I'm just going to correct it. Oh, that's better. Okay, I'm standing here because that's the angle I want. So if I'm standing there, then this will be my opposite and this will be my adjacent. So if I'm saying it's still tan, so it's tan, that's question A, of angle MEN, and it's still going to be opposite over adjacent. So opposite, but now it's 10, and the adjacent is 5. Now it's correct. Okay, you're looking for an angle, so don't forget to press Shift tan bracket 10 divide 5, close the bracket, and your answer will be to 1 decimal place 63.4 degrees. Okay, that was A. Now let's look at B. Angle EMN. EMN. Oh, we're still in this triangle. So it's EMN. We're just looking now for this one. Okay. Now, this is what I wanted to see in the previous one. So if I'm now, but it's not necessary that you do it with SOHCAHTOA. You already have that this one, I want to redraw that triangle. It's necessary now. Otherwise, the sketch is too small and it becomes too clumsy. So let's just, don't forget, that's E, that's N, and that's M. And that's 5, and that's 10. And now I have that this one there is 63.4. That one is 90. You don't have to work. You can work it out again by saying opposite over adjacent, swapping that too, and work with tan. But you can just say that this must all add up to 180. So if I say 180 minus 90 minus this, so actually to find angle EMN, I can just say 180 minus that 90 minus that 63.4, and that will give me an answer of 26.6 degrees. Okay. And now number C, MEF. MEF. Now it's almost like you're working to the top now there, okay? So actually, it's almost like saying, this 2 must give you also 90. Do you see that? So it's MEF. Actually, the easiest way to just do it, because it's, okay, I must just take a ruler. And I'm just going to keep to white. Okay, so there is F now. Okay, and don't forget that this angle must be 90. Okay, so basically to find MEF, I can just say 90 angle MEF will be equal to 90 degrees minus 63.4, which is almost the same. So basically, it's again due to that it's in the middle, that 2 will be exactly the same. Okay, and now the last one, number D. The angle between HB, where's HB? Can I just show you in the sketch again? There is HB. HB and the base ABCD, ABCD. So it's almost like that angle there. Okay. Now, let's just see what I need in that one. So I think I'm first have to, it's again the triangle, so it's almost like I want to work with that and that. Do you see? So first, it's almost like the previous one, I must first get the base. Now if this is the base, and that is 10, and that is 10, so I must now first get, okay, that was A, B, C, D. So I must now get DB. And how do I get DB? By saying, it's Pythagoras, because there's my 90, I have 2 sides. So to get DB, it's 10 squared plus 10 squared, and that's going to be the square root of dB, it's the square root of 200, and that is going, I can leave it first square root 200, otherwise I must work with the approximate, because I'm in one question, then I may not, or in one part, let's rather say in one part D, then I may not approximate. Okay, so let's leave it like that. Okay, so the angle between the base, and now, so I know now that that is square root 200. Okay, and now the angle between, okay wait, the angle between HB, so now I can take out that triangle. Can I show you now? And I can now say that, okay, can I just mark for you? It's again marked in. That is going to be D, that is going to be H, and that's going to be B. Okay, so DB is now, DB, it's that one, square root 200. Okay, and now what do I also have? I have HD is 10. And I must find angle between HB and the plane, so that angle. So if I mark it, this is going to be opposite, this is going to be adjacent, this is going to be hypotenuse. So it's again opposite over adjacent. So I'm going to say again tan of angle HBD and that's going to be opposite over adjacent. Let's just get that pen is now struggling. Just press this on your, and you can just press it like this. Remember it's an angle, so shift tan or second function tan, bracket 10 divide square root 200, close the bracket, and angle H. I know, I just don't get that. H B D, and that is equal to 35.3 degrees. And that's how you do it. So always identify your 90-degree triangle plane. Take it out, draw it that you can see the 90 degrees, and then start just working with 90-degree triangles.